let's dive right into our program. I'm pleased to hand over to our first speaker, Thomas Eule from Saki, and he will show us how robotics and AI are transforming traditional powder handling into a smart, fully automated Factory 4.0 environment. Thomas, the stage is yours.
Okay, thank you for this introduction. I want to share my screen. Is my screen visible? Is it fine? Can you see my screen?
Perfect. We can see the screen.
Okay.
Thanks.
So a very warm welcome also from my side. Our topic today is AI and robotic in powder handling, from a manual process to a smart factory 4.0. I want to show you how a manual process can go into automatic process and smart factory 4.0. But first, let's introduce myself a little bit. My name is Thomas Eules. I am business manager by company Saki. I work more than 25 years in planning and implementation of projects of process engineering in the field of bulk solids. And let me also introduce the Saki company. We are a family business company since 1926, so now we celebrate our 100 years anniversary. Now we are in a fifth generation in a family-owned business, so we're very proud. But we are specializing in innovative robotic solution in a field of bulk material handling for more than over 20 years. We develop, implement, and optimize turnkey plans for bulk solids processing industry. Here we have, let's say, four core systems where we work with robotic. First is smart pick. We empty automatically bags. We have a system smart pack where we can fill automatically bags and palletize in one system. And we can also deal with minor ingredients, micro ingredients with a system smart powder flex and smart tipping by using our robotic systems. But now, efficient and safe powder handling is a major challenge in many industries. Today, I will demonstrate how Saki can bring you to Factory 4.0, and we want to use a real application example for a fully automated mixer feeding and mixer emptying. So that is, I think, what everybody knows here. And let's see, if we would be in an industry, in an automotive industry is mostly fully automated. We have holes, sometimes completely dark, to save energy. But in many processes in our bulk industry, we are using manual powder handling with the risk of employees, quality, and competitiveness. Here we have a lot of problems: quality defects, efficiency defects, and we have human errors. I think all these what is mentioned here is what you know in your production. So let's see a little bit to the basics. We have to talk about Industry 4.0. What does it mean? I think that here we start with Factory 4.1, mechanization. We have 2.0, electrification. 3.0 is automatization. Now, today we talk 4.0, but we are at the moment working on Factory 5.0. That means collaboration between humans and machine. We also have to look a little bit, okay, what does it mean AI in our production, and what is, you also will listen a lot of Internet of Things. What does it mean? Let me explain a little bit. We have first on an example for Factory 4.0. I want to use a refrigerator as an example. A refrigerator is only, he does exactly for what it is constructed. He cools, but he don't know what it is inside, if something missing, milk or expired tomorrow. If we would have an industry 4.0 refrigerator, he would automatically detect picking what we pick. He automatic monitors live temperature, records missing products. So he will talk to us. That is exactly what 4.0 do. So in our industry, therefore means nothing more than it's a combination of real production with the digital intelligence. Let's look what can AI support us. Imagine that every batch what you want to produce has to be exactly same quality, perfect reference batch every time, regardless of external influences such as temperature, humidity, or raw material fluctuations. Here is an example. A human worker will make a coffee sometimes perfectly, sometimes a little stronger, sometimes a little weaker. If we are able to control all these with AI, we can control bean moistures, grit, temperature, and lead time, and ensure that every cup tastes exactly the same. That is what AI do in our powder handling area. And now we're coming to Internet of Things in powder handling. Internet of Things, also simply explained, is if you can imagine that all things can talk and listen to you around. So that is Internet of Things. It will help you in the past. Your operator has to go to a machine, has to check how is the machine looks like, is the material level, quality, everything fine. So now with our IoT, we are able to do also preventive maintenance. We know how is the system at the moment. So now let's come to a solution, an end-to-end automated process. How could it look like? First, we have a smart receive. Our raw material will receive. Then we need a smart transport, mostly to the station where is our production. We need a smart pick, for example. Here I using a smart pick, a robot for emptying bags. We have to convey. We can do it with, my example is a pneumatic conveying system, but we also can use screws or mechanization systems, belts, whatever. We need a smart mix, and sure, now we have all to automate packing. So let's look a little bit deeper in step by step in all these details. So first step is smart receive, seamless digital arrival. The digital process will begin here. Automatically identification of a bag, goods, via barcode, RFID, tags, immediately recorded of batch, material, quality, supply, and time. Then we also can use AI-supported image processing, who checks how our bags looks like, how our pallet with bags is it damaged or not. Here we can use AI. Digital integration into the warehouse management system. So when we have this integration, we have now our raw material let's say, in our system. And we have a full traceability, from the first moment when our product will arrive. Let's look in a step 2. Now we have to transport all pallets to the place where is our empty station. So here on a market, the market is growing, and you will find a lot of automatically transport system. They are flexible, efficiency, and they are really have a high secure. The autonomous transport vehicles, AGV, take over pallet transport contactless to the next station and to our next step. Our next step is now we have to empty the bags. That is, let's say, the critical moment in a process change. That is what it is. It's nowadays mostly doing manually by an operator. But now we need a robot for precise picking the bag and emptying the bag in the discharge station. Here from Saki, we have a patented system with 7 patents, and we pick and place. We open the bag by press the bag to a fixed knife, what it is inside the empty station. We also can use 3D visual system, but in most cases we don't need, because we are support when we pick the bag, we know what the weight of the bag is. We know that the robot is picking on the right place. Several possibilities, but sometimes we use also a 3D system to detect our bags on a pallet. And sure, we need a nearly dust-free emptying, so we have a de-dusting unit on a system. I just show you here a small video and an example, because our system can grow with your application. On the beginning, we start to pick and place a bag into the station. You see the blue one goes in a blue, white one in white. We want to avoid cross contamination, but in some case it could be only just one station, and in that case, here in an example, is every station is prepared for one product, and our product can extend. If you see now here, maybe here is an example for a recipe. What you want to produce is exist of 10 different ingredients. It can be more and it can be less. The robot will pick up according to the recipe, empty the bag in our station. When it's emptied, he will put the empty bag, in that case here, on a bag. We also can clean the bag before the bag goes into the station. Here we have a system for a cleaning bag, and you see we prepare the right recipe. In my example here is the combination is with a pneumatic conveying system. So we dose out the amount of the recipe, and pneumatically will be conveyed into a receiver. The receiver is here in that case directly over the mixer. But we also have a possibility to go in a container, in small buffer beans. It depends on your application and your task. The container can go automatically. Here in that case, he will be empty in one level down. There is a mixer, but also the container can go automatically transport if it's necessary over the mixer. It's just an example. And we also have the possibility to empty only full bags. It's sometimes interesting. Here, in that case, a customer prepare the pallets, and he has to change very flexible the recipe. He produce recipe A, then he has to produce recipe B. Here you need a flexible system and also a system where it is cleanable. We are able to do a cleaning in place and drying in case you have to change your recipe. It could be also a possibility to say, okay, we just empty full bags, but the small quantities we dose over a second system. I give you an example. If you have to dose 104 kilograms, we can say, okay, 4 bags and the 4 kilograms can be dosed with a different system from Saki, Smart Pick, or Smart Tipping. Now let's come to our pneumatic conveying system. Pneumatic conveying system, you can use any pneumatic conveying system what fit and can transport your product. You know, there is a vacuum, there is an overpressure, there is a dense phase, or there is a dilute phase. You can use, in that case, any system to go over the mixer. And now we have a mixer. You see, my mixer is AI driven, so it is not a really mixer. But what I want to say is you need a hygienic design, yeah, because if you want to change product, you have to clean between, and you need AI powered control so that you really know what is the temperature, temperature, how is the situation in the mixing process. And now step 6 is now we have to empty the mixer. So here we also need a precise dosing and packing system. So here we can have we can go directly into the packing system, or mostly you go in a container in a big bag and transfer to your packing line. But here I want to show that it could be possible to go directly under the mixer with our system. You need a precise dosing, flexible packing, and an automatic palletizing system, and a digital traceability. Let's see, we have a system, it's called Smart Pack. The Smart Pack is a robotic all-in-one packing solution for granulate and powders. That means the robot picks the empty bag. It can be an open bag, it can be a valve bag, will put to the station, and we can weld, sewing, and palletize in one system. Here you see an example. Here we have some mixing product, what goes in a container. So container automatically emptying in the system, and so our system palletize. I have some other examples for you, what it could be very interesting. Here is we going directly into mixer. Here we have 2 robots who pick and place the bags, and we have 1 robot here who pick the bags and put it on a belt. The belt is transferring to the second robot, and the second robot is emptying. The system is fully cleanable, cleaning in place and dry. And the empty bag goes here in a sack compactor. If the bag is empty, we are able, in case the bag is the pallet is a plastic, we can lift up the plastic bag, put it in the middle, and the empty pallet goes back and can be picked up by an automatic guided vehicle. Another system is in a bakery industry. Here you see that we have a system where the robot pick the bags. The bags will be emptied. We have here in that case, we have a screw. Screw will transfer into the mixer. If the product is mixed, we also have a screw and it goes to our smart pack and will be automatically filled and packed. So that is very simple application here in the bakery industry, but you see that you can have everything in one level. That is a big advantage. And on the side, you see here a bag empty station. That customer want to add some ingredients manually, but this one is also possible to do it automatically. And here is another system, because sometimes we have really huge amount of products where we have to dose into a mixer, because the mixer has to be, we have to do, for example, 2 or 3 batches per hour. That is why we're using, we're going directly in a buffer bean. The buffer bean is over the mixer, and so during the mixer is emptying, we reload here the buffer over the mixer. That is if you need a really high capacity in your product, but you are 100% flexible. What it means on recipe, you can very easily change your pallets. So in that case is you don't need day silos where you put in your product, where you store, where you're dosing. That is fully automated. And now step 6 is that we need a control, the intelligent control system. It's, let's say, our brain. We have ITO data and IA. Everything has to be combined in the system. So we need a central working IoT infrastructure. You see, that is now a very important that now all data come together in one centralized system. We have an intelligent algorithms for predictive maintenance, process optimization, and energy management. Now, I come to the conclusion. Bag open, mix, bag closed. The Smart Factory 4.0 in powder processing is now technically, economically feasible. Step by step, or a fully automated new line. So you have an intelligent process linking. That is what you need. You need an end-to-end automatization. Manual intervention should be reduced to a minimum. You need a digital networking in real time. You need a modular, flexible system with architecture. Well, a new generation of production, efficient, flexible, and future ready for companies. That is what we can now take in the next step. So we will support you in a way to the Smart Factory 4.0 in a field of powder handling. So we would be quite happy if you send us your task and what you want to do to come to a fully automated production line. That was the moment. I am on the end from my side, and I am still available if you have some questions.
Thank you, Thomas, for your interesting talk. So now, as Thomas said, you have the opportunity to ask your questions over the F&A button that you see on top of your screen. There is a button, it says F&A, and there you can type in your questions, and then I will forward the questions to Thomas so that he can answer your questions. So let's wait a few moments that you have the opportunity to type in. So let's start with the first question. So Thomas, in your opinion, what is the biggest driver for automating powder handling with a robot?
Yeah, when I started the Saki company, I thought, okay, the first driver will be the labor work. But the most companies, they don't like to reduce labor because they want to use the labor on the other side, somewhere else. And what I have found out is that Razer ensuring quality process, reliability, and full predictability is more what it is driven by the customer. You can imagine if your operator can make faults, and when you detect the fault very late in your process, I give you an example by somebody who works in a luck industry. He will operator, if it makes a fault, they will find it very, very late in the process, and that's cost waste and a lot of money. So that is for me. So the driven is not the labor work, it is really the process reliability and traceability.
Perfect. Thank you very much for answering this first question. So let's hand over to a second question. What first step would you recommend to a company looking to transition to Smart Factory 4.0 in powder handling?
Yeah, that's also a good question. The first thing is that you really have to look in your production. Where in your production is manual work? And you have to do an analysis of your recipe. That is very, very important to see how is your material flows, how is your manual steps at the moment. Yeah? Because you know that normally you cannot say, okay, do it 100% automatization from one day to the other day. But we can help you to go the way. Let's say the most companies have to look how you produce in 5 years. If you're by a company, and I ask always, okay, what is your future? Where you want to stay in 5 years? That's it. So please, important, analyze your recipe, analyze your manual work at the moment. That is the first step to come into Smart Factory 4.0.
Thank you. So if you have another question, please type in also your questions over the F&A button. We have a little bit time left. If you do not have questions, also okay. But if you have questions maybe after the talk, then it's also okay that you get in contact with Thomas Eulis directly and maybe ask him the questions then per email or telephone. Or if you want, you can also ask us at Powtech Technofarm via email, so then we can forward the questions also to the speakers. So if nobody has any questions left, I would thank you again, Thomas, for your interesting talk. And now let's move on to our next talk.
Okay. Thank you very much, and enjoy the next talk.
Thanks, Thomas. So we will now start the next talk with Philipp Pahl from Maschinenfabrik Gustav Eirich, and he will show you how you can use AI and data for process optimizations in the bulk guts industry. So Philipp, over to you.
Thank you very much, Clara, for the nice introduction. And I hope you can all see my screen now.
Yes, now you must have the presentation there. Yeah, perfect.
Okay, perfect. Thank you. Yeah. I'm happy today to have the chance and to talk to you in the case of improving the production processes with a focus on bulk material handling. My name is Philipp Pahl. I'm working for Maschinenfabrik Gustav Eirich. In this case, I'm responsible for our digital products and services. And today I want to give you an overview in the talk, not only about the products and services, also about the system and the approach in AI in the bulk material industry in general. Not only what we do, but which trends or which market needs we see for the last years. First of all, I'd like to talk shortly about IRICH, also mostly at the PowerTech trade fair. May some of you have seen IRICH in the past before. We have 160 years of experience in mechanical and plant engineering, so we're mainly famous for mixers in wide variations of industries like the concrete industry, ceramics, lithium-ion batteries, fertilizers, and everywhere where you want to handle raw material in homogenizing mainly, drying, granulating, so different steps of processes. And this is where we originally come from IRICH. And this is the trend in the market I mentioned. We've seen for the last, let's say 4 to 5 years, that the plants, not only from IRICH, but also from the customer fields in general, the plants generate more and more data on one hand, and on the other hand, we see more and more very experienced operators from the plants retiring. On one hand, on the other hand, we have the challenge to find these operators with the experience to have a stable production, to have stable process parameters, and not only in Germany, worldwide we see the trend that handling the operators and the plants very stable is more and more challenging, and that's why we made the conclusion and we set the focus in 2022 to found a joint venture together with process engineers and programmers in the German city of Nuremberg, to found a joint venture called Proseo Vision, which is based in Nuremberg and also part of the IRICH group. And you can see it here in this picture. Therefore, we combine the topics with plants mechanically, electrically, with a control cabinet as we know it, and now improve it with process data, the first use and approach with AI. On one hand, what we see in the little brain here, but the other hand, which is more and more important, is to the process engineering expertise. So there are in the markets there are many companies offering services in data and AI and visualizing process data, but you have to understand the process and you have to know what's going on with the raw materials. And we combine these two disciplines in the IRICH group to have a data-driven process optimization, to build assistance systems for the operators and to improve the customer's process. How do we do that? That's the question now. For today, I want to give you a short agenda with the introduction I already did, then the potential of digitalization in general. And at the end, I think the most practical and most helpful part are the use cases, what we did with our approaches and what the results were. As I mentioned, the IRICH group is coming from mainly mixers, the patent we have from the 1900s, and this is where we're building up the markets. So where we see the need, mainly IRICH plants, is especially with the personal situation, that our customers have problems to, on one hand, find the new operators, on the other hand, to handle the data, especially for small companies. When you want to improve the productivity or maybe save money or in general have problems with the stability of your plant, there are companies who don't have the capacity to handle the data, and this is where we start. So mainly, or some key facts from IRICH, with 16 locations and 50 worldwide representations, stuff like that. 33,000 machines sold. And now we come to the process digitalization. What I mentioned, people and know-how will retire. So we will see the trend that the people who are in front of the plant, operating the plant, the process, their know-how is the most valuable thing in some cases we have. And there we have the challenge to make these know-how assisted by assistance systems, closed loops, and data in general to make the human know-how into data know-how and to have more tools to make the stability, savings and reductions in the plant. How do we do that? We mainly work with dashboards. So we have centralized data, we have centralized visualization, and one important thing, we provide real-time data because we also see many customers having their process, having the data, and at the end, maybe after drying, maybe after post-processing, if you adjust, then it's too late. So we set the focus on real-time data. Of course, what we see in terms of batch time, taking samples. So there are many processes or some processes, let's say, with taking the samples manually. Therefore, you need a human being, and therefore you need time. So we also set the focus on reducing the batch time, which at the end, all of the 3 points reduce scrap and rework. So of course, the early detection I mentioned and the adjustments right in time make your process better. How is our approach? We create a data foundation. So first of all, as long as you cannot measure these data, for example, with sensors, temperature, pressure, cameras, what we see later, you're not able to control anything. So that's why we start with a database and with the situation on site at the customer, what is usable and what data are there. So we have the possibility to optionally build more or implement more sensors. But first of all, we see what's there in terms of investment costs and make one database. And then this is the one thing about AI and the experience we made. Collecting the data is one thing, visualizing is the other thing, but the evaluation of the process, how the material is behaving, which data you want to compare, where you get the result from. This is the challenge we have on our side with the process engineering know-how. And that's why we work mainly with process engineers and not only with programmers, that we can set the focus at the end in the plant-specific optimization with the two disciplines of the process engineering, process know-how, and the software, let's say the data and AI part. And visualizing is the other thing. And at the end, which is the main goal for processes, we have the goal to make closing control loops, what we see later on in a use case. From measured values to process understanding, what we see today is that operators see the signals in a SCADA system, in your control system, where they have trends, alarms, individual values. And in this case, or in the control systems from maybe some years before, you have experience-based reactions. So you see the data, for example, in the concrete, in the fertilizer, in the bulk material industry in general. You see the data in your control, but the reaction, how to add the amount or which amount of water or which amount of liquid, how to set the temperatures. This is in most cases experience-based. And this is also a point and a risk for the next years because you're dependent of these experience. And in the first step, we make these systems and processes understandable and visible, mainly with a dashboard, to have the long-term goal with a closed loop that, you know, not only experience-based, but also supported by assistance systems, for example, with the performance of the plant, or suggestions of the amount adding water, adding liquids, with on one hand process engineers, on the other hand with algorithms we teach, and with these experience from the head, from the operator, we want to make digitally with an algorithm to have closed loops. Yeah, use case one. I start with the practical side. In the fertilizer industry, we made this use case together with Combo Expert in a German company producing fertilizers. And on the right-hand corner, we can see they have 8 Eirich mixers in the plant producing different products of fertilizers. And in this project, the first thing we start, what is the need? The customer wanted to minimize the fluctuations of yield, high yield and constant granulation process. So the amount he had to process several times with the incorrect size of the particles. This is time and money for him, and he wanted to reduce this amount of fertilizers to get more at the end to sell. And therefore we started with cameras. How they will function in detail I will show later, but we were implementing cameras above of the conveyor belts, and these cameras measure the particle size distribution as well as different characteristics of the material, as the moisture and the shape of the particles and the granulations. And these cameras are implemented and developed by our own, and you can see the visualization on the right-hand side. And before, that's what I mentioned before, we had the situation that the operator was going there manually by hand and saying, okay, it's okay or it's not okay, it's too big, it's too small. And here we have a stable 24/7 possibility to measure particle size distribution, to give a trend. You can see on the right-hand side how big the particle sizes are, and this not only works for granulates as long as, yeah, practically we say bigger than 0.5 millimeter. We have a chance to detect it with cameras and an AI algorithm. And this was the first step in this use case, where we were detecting data with the cameras and then including dashboards, like on the right-hand side, by the input of the particle size to make a connect to the set point of water dosing, because in this process we have a water addition and a direct impact to the particle size, and then we made an assistance system for the set point of water dosing. And according to the customer, this set up the production performance or the process performance by 15%. To go a bit more into detail, how we centralize the data, process digitalization with the measurement of relevant parameters, these cameras. So as you can see here on the right-hand side, this is nothing else as a sensor. We also use temperature, pressure sensors to build up one centralized database. Also depending what is already implemented in the customer's plant. And therefore, this is the base for us for the main additional value improving. Here we see a short situation, just as an interest, how the camera system in this case looks like above the conveyor belt. So we have moving cameras up there, implemented with lights, and this is how it looks like with a prototype in this video. So the camera follows the speed of the product, and therefore I think the result is the most important. Therefore, visualizing the results. Oh, sorry. Yeah, this is the point where I wanted to. So we have direct pictures of the material, and we say what the eyes of the operator can detect, the camera can detect as well. And then the view of both cameras and the visualization. Yeah. So the particle size distribution, the size in general, and the amount of particles in a range, for example, if you say I want to have the output range between 1 and 2 millimeters, you can detect the trend here. Here we have an example how it looks like in production. Yeah, so not that clean as in the beginning, but it works 24/7, and therefore this is an important message to our customers. But for AI in general, we come with the message that we don't want to replace operators. We're not there for replacing. We're there for supporting. So as long as we have, for example, cameras in our plant, these data support the operator, for example, or if you're changing shifts, how was the performance of shift 1 compared with shift 2? So we want to support the people, but we will, for now, not replace any operator. And this is an important message for AI as well when you have products and services to go to the market. We also have possibilities to not only measure but to compare different pictures, with a large language model to say material in general, is it too dry, is it too moist, depending on the values, the black-white values of the pictures, which is also an approach we did before. So you can see here in this case the view of a camera above a conveyor belt with a fresh raw material right after the mixer, and therefore we have visualizations to assist the operators in which category or in which material quality they are. Is it too moist, too dry, to help them. Another use case, which is more from the research and development side, is with a research and development center in Weimar, and they have the challenge, or they had the challenge with recycled material from concrete with different colors. So there we have the opportunity and the chance to detect not only impurities, so to detect and make a visualization for the mixing ratio. So when you see pictures like this, how high is the amount of concrete with a gray color and of other material, in this case with brownish color, to detect. So it's also possible not only with concrete or with other particles like sands. It's possible with the color for kind of every material. And use case 3, which is not a whole plant in the very first moment, as in use case 1, which is not a research and development project for the color. Plant 3 is for implementing these cameras right in a mixer. So we implemented the camera to detect the product characteristics right in the mixer. Therefore, we have the challenge with dust, with pressure, and with a lot of other conditions, but it's possible. And as you can see here, this is above of a mixer, so above of the mixing pan, implemented in a camera having insights, because we also have the situation more and more in the market and at the customer side that there is not every time a possibility to have a look into the mixer and to adjust the process. So right in time, I hope you all enjoyed and made some good insights what's possible in these technologies with AI, with cameras, and with improving process technology. Here you can see a picture and contact data of me and my colleagues from Vision, and we are every time happy to help you. So in case you have a challenge in the process coming to this, please let me know. And therefore, I'm ready for questions. Thank you for your attention.
Thank you, Philip, for this interesting talk. Very, very nice. And thank you for, your speak. So as Philip said, you have the opportunity now again to ask questions to Philip about his talk. And you have the F&A button that's on the top of your screen, where you can type in your questions, and then I will forward it to Philip. So please feel free to ask, and I will give you some seconds that you can type in. So let's see and start with the first question. So how do you address concerns and resistance regarding data logging and artificial intelligence in production environments?
Okay. This is a very important point in terms of the contact with customers, that we have the approach not to, as I said, not to replace the operators, so therefore to assist, because having these data and visualizations and algorithms, cameras is nice, but you always need the operator on your side, because they know the processes sometimes the best. And that's why we go there and say, okay, we program or we develop assistance for you and not replacing. And in projects, what we did or we had in our experience, that the very first step with the customer is not only the production manager and the CEO or sometimes some higher people, let's say. We also talked in the very first round with the operators to have them in loop, that they have very transparent what we do and what our goal is, and then to fill the data banks with the experience and the knowledge. So to have them in loop, to talk to them in the very first step of the project, and to have the message that we assist them and not replace them with AI.
Interesting. Thanks for answering. So let's see. We have another question. So what sets you apart from traditional data analytics companies that offer data-driven process optimizations?
Also, another point, because here we had use cases from the fertilizer industry as well as from the building material industry, but our let's say additional value is that we have experts in industry as ceramics, lithium-ion batteries, fertilizers, all Irish main industries. We have the process know-how, and therefore we combine these process know-how and also raw material know-how with the software and, let's say, the AI development know-how. So there are providers of only data systems and visualizations and AI in general, let's say. But one of the most important things is what you do with these data you collect and you visualize. What's the next step and the reaction in the process, and therefore you have way more influences as only the data.
Perfect. Thanks. Hope this answered the question. Another question is, do you have a clear architecture for how the data will be collected, stored, and analyzed?
We don't work for now with clouds. Yeah, so we don't work online because we see the customers trend and behaviors that the data security, of course, is one of the most important things. And we don't save these data on worldwide servers or clouds, especially the very sensitive data of recipes. We work with offline IPCs, in this case with local storage data banks. So it's on the customer side. We have a remote service access if the customer allows us to make our work and to improve. But the data and the architecture is structured that it's on the customer side.
Perfect. So we have another question. I think you answered a bit of them also in your last sentence. But where does the data analysis take place? Locally at the factory or externally at ProsoVision? Do customers consent to the data transfer?
From our experience, we have it 50-50. Yeah. But first step is on the customer side to get the insights, to get the database. We often have the case that on site you see that there is someone standing typing in an Excel sheet, yeah, or making it manually, handwritten, which is the practical side. And therefore we start on site, talking to the people, having a process overview, and then taking this information with us with a secured storage, and they then start the data analysis from Nuremberg. Another point is very first moment at the customer side, because we have to understand what's the goal of the customer. Yeah, reduction of time, consistency, stability, moisture control. What does he want to do? And that's why we start at the customer side at the beginning.
Perfect, thank you. So we have another question. So the person said that he sees in the presentation that you also talk about data collection and visualization using Grafana. But the question is, where do you use then AI directly?
That's right. The visualization in AI is in general nothing. In Grafana is basically nothing new. AI in this case is the detection of the particle sizes. So we have pictures we do in the plant as shown here, with different sizes of the particles, and there's a mathematical algorithm behind that we say, for example, here the particle size is the shape. What is the D50 of all these particles? And the calculation of the sizes of these particles and shapes in the visualization. To do that with Grafana it's not AI, that's right. But to make a picture and to have the information about the particle sizes, there's more behind than only Grafana.
Perfect. So hope this answered the question. If not, you can also get in contact with Philip afterwards and discuss much more about this topic. So I will ask you one last question. So how will the field of artificial intelligence in bulk material handling evolve over the next 3 years? What do you think?
That's a good question. I'm not a fortune teller, let's say, but I think we will have more and more upcoming companies on the market providing software, and the market with private use AI. Everyone knows ChatGPT or something, which are not that ready anymore to pay for that. So you really have to focus on the additional value you have. And the speed of the market developing new tools is increasing. People are used to these agents, AI, LLMs very, very fast. And that's why you have to be fast in developing and offering these services. And on the other hand, let's say in all AI bubbles and possibilities to not lose the base of understanding the process, because we also had tests with big LLMs to make a let's say AI-based process tools without anyone controlling any operators. And it's not that in the process industries, it's not that good as everyone means with the output you really want, let's say. So having the base and understanding the process, and then taking the tools with the speed, but always have the use for the customer, and not only saying we're using AI, and that's it. Yeah.
Yeah, let's see what's going on in the next years. Thank you very much, Philip, for your interesting talk about data-driven optimization in the bulk goods industry. And then we will go on with our next talk. So let's start with the next talk, and also the last talk for today. I will hand over to Sebastian Pohl from Greif Velox, who will show you how data and AR are transforming packaging machinery and driving efficiency and availability in the packaging 4.0. So Sebastian, your turn. Have fun.
Perfect. All right. Good morning from my end. And
you can also maybe turn on your video so we don't see you as a person.
Sorry.
Yeah, now, perfect.
Perfect. So, all right. Good morning again. Today I would like to talk about how to leverage AI, or what we can do to leverage AI to improve your packaging. And before we go right into topic, I would like to introduce our company to you. We are Greif Velox, a worldwide manufacturer for bagging and liquid filling machines. So you will find Greif Velox gear in each and every plant in the chemical industry or the food industry, where they are bagging dry solid products like powders into valve bags and FIBCs, or where they are filling liquid products into jerrycans, drums, or IBCs. And as you can see on the map, our machinery can be found all around the globe. So this is where we leverage our solutions. Whenever we do look at packaging or at a packaging task, we always look at the three most important parts and pieces of the packaging, and it's our target to bring together product, container, and the filling system. And this is also where we try to look into when we do talk about AI and IoT. Okay, but today I would like to talk about the latest trends in AI and IoT when it comes to packaging. And I would like to give you some real-world examples how we are leveraging AI and IoT to improve the packaging of our customers. Where do we see the most relevant trends when it comes to the use of AI in process packaging? And the most relevant trends are condition monitoring, preventive maintenance, predictive maintenance, OEE monitoring, data-driven process optimization, and last but not least, packaging as a service. So in a nutshell, what does this mean? This means that we do see our industries using AI and IoT to make data visible, to get all the data they are generating from their bagging process visible 24 hours a day, putting it into a data bank, and being able to also look at how the machine is performing remotely. They go one step further and use this data to create preventive maintenance and predictive maintenance programs And preventive maintenance means that we can support our clients with analyzing this data and having the know-how about runtime-based maintenance plans and runtime-based replacement plans of critical components, so that we can support them in making maintenance plannable, which is like the major goal, because you will not find any technical machine which is just running without maintenance. It's always about making it plannable. Predictive maintenance is like the big brother of preventive maintenance, so that you can not only do this runtime based, that you can do this incident based, and that we are monitoring certain components in the machine to really predict when they might fail and build this into their maintenance program. Of course, you can also use all this data you are generating to optimize the fitting process and to generate even more data to identify critical parts and to twist and tweak around how to optimize the runtime of the machine. If you do look into the industry and run some research among all our industries, the top trends, or what is it where the leading experts are looking into, this is IoT, predictive maintenance, and maintenance analytics. So those are the topics which will create the biggest momentum in the very near future. Giving you some real life examples how we already do leverage IoT. For example, this is the continuous measurement of the filling pressure in our bagging machines. And what we do here is that we continuously monitor the behavior of the process air, which we are using to make the product flow in the hopper of the bagging machine. And by measuring those parameters, we can enable the bagging machine to early detect a bag breakage. And why is this important? Because you can all imagine, if a bag leaks or if a bag breaks, you have to stop the process, you have to clean it up, you have to bring in new bags and restart the process. So on the one hand side, the customer is losing time for the cleaning, the customer is losing product due to the leakage, and what's even more important is the customer is losing process reliability, because as you all know from your production processes, a continuous and stable process is the most accurate one. So what we can do here, again, is we can use the real-time data collected from different pressure sensors to early detect bag breakage and announce the customer to take the wrong bags out of the process before they leak and before they lose a lot of time for cleaning. Second very nice example of IoT is our remote service program. So with our remote service program, we do enable our service department to remotely hook up to all the machines in the field. So in case there's a malfunction, in case there's a question because some operators changed the program and cannot get it back to performance, they can call in. We can securely hook up with the machines in the field and really enable the teams on site to solve the issues without travel, without time delay. So like you can see here, typically 95% of all upcoming service or support requests can be resolved within the first 24 hours. If we go further into predictive maintenance, we did talk to a lot of clients to find out where the benefits are. So what is the benefit about a predictive maintenance program? And in a nutshell, this is all about making maintenance plannable and making it more cost efficient. So predictive maintenance enables you to reduce your downtime because you can early detect failures before they appear. And if it's plannable, you can do it without a breakdown and without all the costs being needed for cleaning and unscheduled personnel you might need. It's a very cost efficient if you do use AI to plan your maintenance, because this enables you to reduce your operational costs, because it's only, or you only do exchange the parts and pieces which are coming to the end of lifetime and which need to be changed before you are losing performance or actually creating a failure. So very cost efficient on the one hand side in the service, on the other hand side in the parts. If you are running an health monitoring of your system, you can even see how the different performance parameters are behaving. So we do enable our customers with tools in order to identify the most critical parts of their filling and bagging processes. And I will show you those health monitors we can offer later. And based on those health monitors, the customer is enabled to really identify the critical assets and the critical process steps. Based on all this data a customer can generate, you can automate workflows for service and maintenance and optimize your maintenance strategies, because parts only need to be replaced when it comes to an end of service time, or when the data generated by the parts, the measurements we can take from certain parts in the machine, do send a signal that maintenance is necessary. And again, the biggest momentum you can generate by making maintenance plannable and doing it outside of your high utilization production times. What is actually the impact of the improvement given by predictive maintenance? So within just 5 months, you can reduce your common failures up to 75%. And this is not data which we are only building up as a sales promise. This is data generated from studies across the industry. So there's a very big potential in implementing predictive maintenance programs for your manufacturing. A real life example, where do we already implement predictive maintenance and self-testing into our machinery? And one very easy example is the flap you can see here. It's a product inlet flap, and this product inlet flap is tested by air every morning and continuously during the production process. So whenever they turn on the machine, and also continuously during the process, we do measure the air in the valve, and so we can measure the wear, because when the wear goes up, the airflow goes up through this flap, and so we can tell the customer when this flap needs to be replaced, when they need to order the spare parts, and incident-based, they can plan their maintenance on the sealings of the inlet flap. Whenever the customer is just replacing the sealing of the flap, they can prevent of really breaking the whole flap, which gives them a second advantage, that downtime can be shorter, and also the whole maintenance costs are lower, because not the whole component, just the sealing needs to be replaced. We already talked about maintenance analytics and analytical tools to really identify the critical process parameter. So we do support our clients with OEE dashboards, and with those OEE dashboards, the customer can analyze the real-time data generated from their bagging machine, and they can not only look into detail on the performance per hour and on the accuracy, they can also break this down into certain components of the machine. So it's not just the whole machine, it's also possible to break it down into the important parts and pieces of the machine and identify the most critical and most influential parts of the machine to really improve the maintenance schedule of your machine. We will take this further. So what is next? What is next, and how can we really leverage AI and data to improve the bagging process of our customers? And I would like to give you a little example of something we are working on, and which will be there in the near future. This is a bag quality control device, and as I explained to you in the very beginning of the presentation, if you really want to achieve a great packaging result, you need to bring together the container, the product, and the bagging machine. And with this bag testing station, you can run an assessment of the paper bag. And by running an assessment of the paper bag, the bag is checked on air permeability, on leakage, on performance under vacuum, and also on firmness of the bag. By generating this data with our bag test station and submitting this data to the Velovac filling station, we are able to really adjust the bagging station based on every new pallet of paper bags the customer is bringing to their process. And this might vary from time to time, as also the bags are made automatically in an automated process, and there's a tolerance and a spec, and as long as the bags are in tolerance and in spec, they will work. But again, bringing together product, machine, and container enables you to really improve your bagging results. Last but not least, bringing together all those tools I've shown to you, we will be able to launch our Velo Expert program in the third quarter of 2026. And in this program, we will allow our clients to bring together all the necessary parts and pieces, whether it's real-time condition monitoring, remote maintenance, predictive maintenance, and also inventory-based consumables and inventory management for consumables and spare parts. Because with all the data we can generate from the bagging process, this enables us to allow the customer to get all the data in one place, which is the Velo Expert program. So, summing this up, and the big question we are always asked by our customers: how can we get started? And what's the most important if we really want to get into AI-driven or data-based maintenance improvement? And what we always tell the customers is that there's four big steps. And the first big step is that you need to identify your most relevant process data. So you need to understand which is the parameters which will tell you how the machine performs, how the quality is, and how the machine operates. You need to enable your machine and your process to systematically collect this process data. So you need to bring in place the right sensors, the right measures, and also, which brings us to the third point, you need to establish a secure data connection where we can help you to generate this data, to bring the data together, and process the data. Last but not least, continuously train the AI. So with just generating more and more data, bringing more and more together different data points, this will allow us to even improve the intelligence behind those models a lot. The good news is the journey has just started. So there's nothing yet where you can say, hey, there's the big bang and you have missed the trend, but we will see big improvements in the very near future. Thank you very much. Any questions?
Thank you, Sebastian. So let's see what you have for questions. And please use also, again, the F&A button at the top of your screen to type in your questions, and then I will forward it to Sebastian. I will give you some moments. Perfect. So let's see and start with the first question. So how far has the industry really come when it comes to data-driven maintenance?
Yeah, like I said, I think we are just at the beginning to really understand what the power of data-driven maintenance is. And what we do see more and more, and what we do appreciate, is that everybody is working and everybody is interested in data-driven maintenance. And the most important point from my point of view on this is that the industry, so our clients, do allow us to work with the data. To answer your question, we are just in the beginning, but we are making big steps because everybody sees, or everybody starts to see, the benefit.
Yeah, I understand. Perfect. And another question is, are we already at the point where machines can anticipate problems, or are most companies still reacting too late?
Good question. I think it always depends on how far you are with understanding your process. So, for example, if you use the little example I gave you in my presentation, yes, we are, and we as Greif Velox, we are at a point where we have identified some of the failures which might make a big impact, and we are working on making those visible and making those predictive. So I think this is exactly the way where we are on, the path we are on at the moment. And there's some industries where this might be easier. So, for example, if you do look at the lubricant and bearing industry, they have made big steps in the latest years, and they are using ultrasonic sensors to really monitor and lubricate. And so in different parts of the industry, we are more further than in others.
Perfect. And do you also know how close how close is the future where production systems can monitor and optimize themselves?
We will see. Yeah, I think this is what we will see in the next years coming up, and which will be a big trend, where with all the very fast developments in the big language models, in the big data-driven models, we will see companies leveraging all the data they are generating to build processes which can optimize itself. And this is like the example I did show to you about the back testing station. And the first step will be that this is technology you can use to test the bags. And the next step will be that this technology can be integrated into your machine to really build a self-optimizing filling technology.
Mm-hmm. And also one question is that if you have an idea about the return on investment for monitoring a machine?
Yeah, like I gave the example that you can reduce your maintenance cost just within 5 months for 75% if you do start to do preventive maintenance. And so what we do see on the return on investment on the technologies we are bringing to market, this is less than a year. So the investment will pay for itself within a year.
Crazy. Okay. And maybe a key question, I think, is it, are we still reacting to problems or are we finally starting to predict them?
I think this is the key. This is the key message, or this is the key message we are always telling our clients when we do discuss about preventive and predictive maintenance programs. Because the problem itself, so the failure of the machine or the failure of the small and little part of the machine is not their issue. The biggest issue is that it's unplanned. Because if you do this, your production is shut down when you are in your monthly, weekly, annual maintenance, and it's not happening out of a sudden. The maintenance crew is there. You are not losing production. You do not have any idle time. You don't have to wait for spare parts or technicians to be sent. So if you do implement preventive or predictive maintenance programs, of course, there's a cost for it, but the return comes with the plannability and with reducing the impact. So this being said, in the end, everybody who is doing preventive and predictive maintenance is working the right thing, not to just recover from problems, to work on solutions before problems appear. Companies which are just following a strategy where they are using the machine until it breaks. And I would say nowadays, this is 50 to 60% of the industry still following this kind of strategy. They work on solving problems faster than creating solutions.
So now we must also creating solutions and not solving problems in the future. That's the perfect way, maybe. And I will come maybe with this last question also to an end. I think that's a good ending for the whole virtual talk today. So thank you again, Mr. Sebastian Pohl. Thanks for the interesting talk, and also to the other speakers today. Thank you for your time and your interesting insights.
Thank you.
Perfect. So now we come to an end. I will show you another slide from my side. So thank you all of you for joining us today, and also we're having our upcoming talks. So please check our website and also our LinkedIn channel. There we're regularly posting some new dates and topics for our virtual talks. And also I wanted to invite you to PowTech Techno Farm 2026. Is taking place from 29 September to 1st October this year in Nuremberg. You also have a QR code here on the screen. If you wanted to join us as an exhibitor, please feel free also to scan this code and see there all information about the prices, the hall plans, etc. And also you're welcome if you're not attending as an exhibitor, you are also welcome to attending as a visitor on the 29th September to 1st October in Nuremberg this year to PowTech Techno Farm. So we have a key highlight. Maybe some companies here in this talk have an interest on it. It's called the Smart Industry in Focus Pavilion. It's dedicated to automation, AI, and digital production technologies, well, perfectly aligned with today's theme. So if you're interested in exhibiting here, that's a whole package exhibition opportunity, please feel free to contact us. So now I'm at the end with my part of advertisement, and thank you once again for being with us, and we look forward to see you at the next virtual talks.